that really significant build-up, Tracy. So we're here to talk about the Australian curriculum, and yeah, that's maybe not quite as exciting as that. I'd love to be handing out. Yeah, I'm so with you. And I love big history, and I'm a science teacher, and when I first kind of heard I'm teaching big history, I went, oh, okay, what's that about? And then I had a look and I really loved it. And big history is just the whole platform for putting everything together so it makes sense. The thing I liked about it most is this little quote here, which comes from, in fact, a professional futurist. So, yeah, we are accustomed to thinking that the past, you know, sort of shapes our future, and that's why history is important. But what's really important is what your perception of the future and how you view the future, and that's actually what shapes the decisions that students will take here, which will make a better future for them and for us later on. So big history is the power. It's the power of history. Make it work for you. Right, so Australian curriculum, yay. Now, some of you are probably kind of going, yep, all right, I've had a bit of a look at, you know, the New South Wales curriculum and the big history overall and 9 and 10. You might be thinking a little bit along this kind of lines, but it is actually easier. If you think outside that square a bit and just move into how big history can actually work for you, it really does work. Now, this is a slide from David Christian's presentation that he gave to the Principals of Institute of Australia, and he's trying to illustrate that big history is something that connects all of these disciplines. So we rarely just learn knowledge as a silo. Everything that we actually learn about the world comes from different perspectives, different angles, different disciplines to have it to all bring together to make sense. So yeah, kids are sitting in different classrooms learning about different disciplines, but to really get that picture of the world, if you bring it all together, it makes a lot more sense. And so that's what we can do with our friend, the Australian curriculum. Make it work for you. Don't get stuck the other way, trying to ram it in. So we're basically going to run you through a little story of big history, 13.8 billion years, and we're going to make it pretty quick. And then we're going to show you how that you can use this to engage, empower your students, and teach them what you need to be teaching as well. So here's our timeline of which you're all familiar. Strap yourselves in. Let's start off at the Big Bang. So as Tracy was saying before, these threshold cards are just a great way of organising the course, so it means, brings that sort of sense to the narrative, makes everything easy for the kids to make sense of that huge amount of information that they're about to learn. Basically, the Big Bang, we start off, you know, concepts for history teachers might not be that riveting, but what you're wanting to say to the kids is this stuff is amazing. This is history. It's not just science, it's history. Everything started from this tiny, infinitely hot, dense singularity and then the great expansion. Now, as we went in the early stages, there was kind of this plasma state and not much was going on, not much complexity. Remember back to Tracy's. Now, about 377,000 years after the Big Bang, things had started cooling down enough so that we could get atoms that formed. Atoms were important because all of our stuff is made from them. At the time, a little bit after that, 380,000 years after the Big Bang, things started to change again so as that we got the cosmic background, microwave background radiation. Again, if you're a history teacher, what's the important thing to know about this is that this was in fact a huge piece of evidence for the Big Bang. So we're talking about here our story and how it's a scientific origin story. This cosmic background, microwave background radiation was something that was in fact predicted that it would exist, and then people went looking for it and then they found it. So massive piece of evidence to actually show when we're talking about claim testing that we can actually work these things out through logic and claim testers. The cosmic radiation kind of looks a bit like this from a WMAP satellite, little patches there of temperature. Now these here red bits are 1/1000th of a degree hotter than the blue, but that's really useful for us because that allowed the energy to congeal together into matter. So before there's this plasma state, everything's just all together, not much is happening, cools down, starts to congeal, we start to get matter that starts to form, and that's the bit that matters. Matter matters, because now we've got stars. So a star is this little singularity that burns by its own light, and that came together with the ingredients of hydrogen, helium, helping along with a bit of gravity. And then of course the stars are really important to us, as we'll see in a minute. Lovely, look pretty, all good. Stars have life cycles, stars can be classified. We can talk about our favourite star, the sun, so kids can be engaged and interesting, and this sort of stuff can be made a bit personally relevant. Why are stars of interest to us? Because essentially, when a dying star, a high mass star, ends its life in a spectacular supernova, that creates all of the elements in the periodic table. Yay, all you science teachers, you're loving this. History teachers, you should be loving this as well, because the periodic table gave us all of the elements to make all the stuff in the universe. And from that, we can really start to see complexity happen. If you're a science teacher, you'll obviously be working in with the Australian curriculum flagging, oh yeah, chemistry, I've got that going on. We had our physics, now we're moving into the chemistry. All of the biological sciences are yet to come. So, you know, the science curriculum is falling into place pretty neatly with this story. From here, we can talk about threshold 3, the new chemical elements. So, ageing and dying stars were our ingredients. As they forged together in this huge temperatures that came together in the centre of that star, they managed to bang the elements together and together and together until they formed the heavier ones, and eventually we got all of them. Once we had the heavier elements, we could then start to get a lot more complexity. Science is a human endeavour. You can talk about people here, Dmitri Mendeleev. So this guy was this kind of Russian peasant. His dad had died. His mum had recognised that this guy was looking like he was pretty promising at school, so she rode him half the way across Russia on a horse or a donkey and tried to take him to university, and the first one said, no, sorry, not interested, so she turned around and rode him back halfway across Russia on another donkey. Here can my son go to school? And yes, they let him go, and then he went on to develop this amazing system of classifying the elements based on the properties that their electrons, neutrons and protons displayed. And he was so sure that his system worked that even though a lot of the elements had not actually been discovered yet, he was able to predict their properties based on his formula. And when some other early alchemists decided that they, said they've come up with an element and they've described it and discovered it, he said, no, you're wrong. That one doesn't fit the method. Something's happened. And sure enough, he was actually right. So he argued with the other scientists, your newly discovered element doesn't fit my table, and in fact he was right. So another just way, with this story of science, making it interesting, science is a human endeavour. How do those things that we learn about in our chemistry class mean anything and mean, part of a good story? So chemistry is pretty cool. You can talk about the ways that different chemicals combine to create, carbon in its different forms, some of which is more preferable than others. Chlorine gas, pretty nasty, mix it with a bit of sodium. Hey, you get some tasty salt, which has probably got its own dangers, but anyway, don't worry about that. Phosphorus I really like. So some of the early alchemists in the early days who were dead set that this guy was going to turn other metals into gold. And he decided he'd do this by distilling huge vats of human urine. I would like to be joking, but that's actually what he did. Massive, massive vats, getting that, so. Yeah, well, and yay, so is gold. We and gold. Awesome, it's got to work, yeah. It didn't work, but luckily along the way for that, he discovered phosphorus, and that was really helpful for early lighting and matches. So, just these interesting stories. I would love to tell you tons more, but we're racing through it. So, after we've got these heavy elements, we can then get our next threshold, which is the Earth. Earth is obviously a really important spot to us. It's a nice rocky planet. We've got gaseous planets that formed from the lighter elements. And as this thing called an accretion disk, so all of this matter that was spread out into the universe after the Big Bang that all came out, as this comes together and spirals around with the gravity, we start to get these planets forming. So a gassy planet's fine, but a rocky planet's awesome. We want a rocky planet, and we got one like this. So this was the Earth in its early days, pretty kind of rough looking spot, and in its early days as well, lots of bombardment happening. Things were coming in, flying all over from the space. So this here, it was projected that the Earth was hit by quite a large object that then went on to be our lovely moon. So that was pretty good for us. That was something that worked in our favour, because of course the moon sets up, all of the stuff that you should have already taught the kids earlier on, tides and all the rest. Now, we go into our earth sciences here, and a lot of people go, oh yeah, all right, here's the diagram that we all know. We've got the molten core of iron. Why is that important to us? Why do we really like that molten core of iron? Who cares if the Earth is a molten core of iron? We're not going to see it, or does it matter to us? Well, it does, because that molten core of iron sets up this gigantic magnet around the Earth. And that deflects all of this huge amount of solar wind to stop us just getting all blasted off the little Earth. So that magnet is an awesome thing, very useful. All that solar wind would have just blown us away. Solar wind does make pretty auroras though, which are quite nice, but lucky we've got that magnet. So just relevance to the kids, you know, all of this stuff that you're learning, make it engaging, bring it in. Why is this stuff good? Why should we know it? How does it help us in our little existence here on our planet? So once we can start talking about that, we've got a whole lot. Tracy alluded to this guy before, Wagner. So he was in fact a balloonist and a meteorologist. He was cruising around in his balloon and he noticed, oh yep, look, these continents kind of look like they could fit together as a map. But he was sort of laughed at for a bit. Then as the theories are contested and refined and new collective learning and new ideas come together, people started to notice, hang on a minute, there's some fossils here. Some on this side, some on here, some over here, some over here, and hey, look at that. If they match up together, there's some evidence. Maybe this guy had a point. Developing along. Make tectonics fun. It's awesome. New collective learning. So we've got these sort of ways that, you know, we can claim test again and moving on with the theory. So lovely year 9 science example here for people. Just plug for the scientists. All right, so within the Big History Project, they actually do have some interesting little units that you can use here. This, I think they commissioned a travel writer to go out and talk about volcanoes and stuff like that you can read, just student engagement materials to support that. Moving on to life. Once you've got your rocky planet, things have cooled down a bit, we can get started with this awesome evolution. Potentially, life started out somewhere like this, these sort of black smokers, because you've got complex organic molecules, some liquid, which you need to help hold the things together, and some energy to get that process started. So a few people have had a shot at trying to create these in laboratory conditions with, you know, moderately low levels of success. But basically, we're still theorising on how that first life got underway. Possibly, life could have got started quite a few times on Earth. So we're not actually saying that, you know, our strain was the only one. It might have started and just been a fizzer. But our strain took off, and one of the ways that it uses, you know, to copy on to its next generations is with DNA. So we can tell that DNA is the blueprint of which all living things now use, and that's why we are deducing that every living thing came back from a common ancestor, because it all uses this system. And it was incredibly complex to have evolved, you know, potentially different things here and there. So we're not saying this was the only life that ever occurred, but because it didn't leave any fossil record, we'll just say that we're it. So I'm going to give you a massively condensed version of how DNA fits with evolution. Here is our molecule that we all know and love. So here's a DNA molecule that copies itself billions of times across all of the cells in all of your body, and then every now and again it makes just a tiny little mistake. But that doesn't have to be a bad thing. So these little errors, or copying changes, we'll call them, in the DNA, can go on to create this huge amount of species diversity. Because if a little change in your DNA turns out to be an advantage, and if you're in an environment where that organism can capitalise on that, it's more likely to breed, more likely to reproduce. Thank you, science teachers nodding, we're away. And that brings out this whole diversity of life on Earth, just from these teeny tiny...
We'll tell you when you get wrong.
Oh, thank you. You'll tell me when I get right. Yeah, right. All right, so feel free to jump up and have a shot. So we're going pretty quick though. I'm about to hand over to the history side of things, so I'll be free at lunch to talk about this more in detail to everybody. So from a Australian curriculum perspective, if you're working with science, you're just seeing this covering off on everything. So year 10 science, DNA, evolution, it's all in there. The way that the species interact with the biosphere and single cells organisms. This is, as I said, a really very condensed version, but in the Big History course website you'll see that there's a lot of material to support that. So We start kicking off with our evolution. The atmosphere starts to change, the oceans here. Shout out to the Western Australians. Here are the stromatolites pumping out oxygen into the oceans. After a time, that climate changed so much that species thought they'd have a shot at moving onto the land. They were climbing up, gulping a bit of oxygen. Somebody thought of a great idea of having an egg, because then you can take a bit of the water with you. So now you can breed outside of your water because you're taking your egg with you. So quite an evolutionary leap from the old egg. After that, the carboniferous forest started to take off, huge amounts of oxygen in the atmosphere, supersized stuff, those huge dragonflies, everything was changing. We got our mates, the dinosaurs, who hung about for quite some time until, bad luck for the dinosaurs, but good luck for us. Because that led to the evolution of the little cute little mammals. So climates had changed, atmospheres, thank you. We're moving, and the species now who are adapting to the new climates are evolving. Changes, remember, in the DNA, changing to the climate. So we're moving, the little mammals, more recognisable mammals, higher mammals, moving on to the humans. Handing over to my history colleague here, who's now the history teachers are looking good. Going to run you through the next part, and then we'll get back into some curriculum.
So, how do we evolve? What makes humans different? This is where we jump in, history teachers. Or where the curriculum tells us to jump in anyway. So, as Chloe was just saying, every little living thing on Earth comes from a single-celled organism called Luca. So, that's our ancestor. We're all related to Luca, grandpappy. And I find that fascinating because it means that we're all related to bananas. Did you know that we share a common ancestor? 1.5 million years ago, bananas and us have a common ancestor. That's not half as recent as 1 million years ago, us and chimps. So, yes, we're all coming into these evolutionary things. Chloe's already talked about the dinosaurs. I think that's hilarious, but that's just me. I don't know if you can read it from where you are. So we've got mass extinction of the dinosaurs. As Chloe said, all the cute little mammals are like, yay, I can now go and thrive. Primates, tree dwellers. Of course, they had to evolve things like their little thumbs and things like that so they could grasp onto the trees. They had to have 3D vision, eyes moving into the forward position. They had to have big brains because they were searching for food that was hard to find. And bipedalism, someone needs to understand why there's chickens' legs up there. And, you know, hey presto, around 40 species of hominins. And today we're down to one. All right. What the hell have all these got to do with any of it? Some of these are my favourite things. Not so much shoes, I don't know why I put them there, but wine sure as hell is. Snowboarding is, and a device that keeps my food cold is, because I like food. So what have these got to do with anything? Well, humans evolved, and when we evolved, what separated us from all the other hominins, what has separated us from all the other animals, what has separated us from everything to the point where we are the only species to ever dominate the Earth's biosphere is our ability to collectively learn, to learn from the previous generations. And none of those would exist without our ability to do that. And that's the next threshold. Okay, so threshold 5 was evolving. Threshold 6, we've got collective learning. So the main ingredients, of course, are these powerful brains that began because primates had to look for tricky fruit. Precise, versatile, symbolic language. Okay, the ability to communicate these things that we have learnt. And then this Goldilocks condition, you know, has anyone explained the Goldilocks condition, the Goldilocks where it comes from? Not too hot, not too cold, just right, Goldilocks porridge. All right, so it was just right, the interactions between individuals and between communities to get to this new complexity where we have this incredible ability to learn. All right, I've got to make it quick. Then collectively learning plus beautiful conditions on the climate meant that we could come up with agriculture. So moving very, very quickly, but history teachers, as we know, we do teach, it is in the curriculum that we teach, and it is in big history. We teach them migration of modern man out of Africa how we migrated around the world, and we look at how our life then, the hunter-gatherer lifestyle. It's all in big history, it's all in our curriculum, and then we get to agriculture, but we are speeding through. So agriculture, why is it important? Without agriculture, and this happens all through big history, as we know, this is the beautiful links from the Big Bang to the future, is everything is. This wouldn't be without this, which wouldn't happen without that. Okay, we wouldn't be here without an asteroid getting rid of the dinosaurs. Without agriculture, there wouldn't be these things. Some of them are a little bit confronting, okay? But they wouldn't be in existence without agriculture. So again, it's that lovely threshold of where you've got these key ingredients at exactly the right Goldilocks, not too hot, not too cold moment to get this new complexity on our little blue planet. Okay, so our knowledge, our collective learning, okay, our increasingly dense communities combined with competition for resources, and the last ice age is over and things are getting warm and cosy now on the planet, means that we domesticated plants and animals, villages, cities, and as we know, once the farming started, the villages, the cities, the civilizations. We teach that in the curriculum. Isn't that nice? All right, then jumping ahead, we're getting into the Year 9 curriculum. How did the world become interconnected? And why was commerce so important? I don't know about New South Wales teachers. Us Tasmanian society and history teachers have just been told we have to teach economics. It's really interesting. It's not my strongest point, being an English society and history teacher. Anyway, moving on. So Year 9 curriculum, we've got all this expansion and connection. So we know that there's these beautiful ancient trade routes, and it blows my mind that at a time where there was no modern means of travel, people were travelling this much. And that collective learning was taking off. People are getting all these amazing, juicy ideas off each other. I've been lucky enough to travel around the world, and I was just like, whoa, this is amazing, check out all this stuff. I'm learning so much. But I knew it existed. These guys are just walking in fresh and going, wow, just taking on everything. This is today's, airlines only. So, we're connected through ancient trade routes, collective learning took off. Check out today, that's just airlines. You can't even see the line between us and Sydney. That's just the boating routes. So, we're a little interconnected these days. I didn't get the one up there, but there's a beautiful one of internet as well. And if you put all three of those over the top of each other, wow, we are so interconnected. So this is getting us into threshold 8, the modern revolution. What's that you say? This sounds like it's getting into the Year 10 curriculum. Okay, so we've got increasingly large exchange networks, vast accumulated information. We've got those new energy sources. Oh yeah, Industrial Revolution, Year 9. Got these Goldilocks conditions of the globalisation of the world, the promotion of commercialisation, which is accelerating innovation, and this new complexity. Okay, a globally connected human society. It's the norm for us, but this is really recent stuff. Enables increased control over and consumption of resources. Well, we know that, it's a bit of a sticky one. And leads to rapid population growth. Okay, and as we all know, we've gone over that 7 billion benchmark now. Okay. So, and those, I've just put up there, I don't know, I haven't been reading them out, but as we know, those connections. So, that the collective learning and, the threshold, it moved us into agriculture, so farming moved to larger networks, which led to people becoming specialised in trade, because of course we didn't have to spend all our time hunting and gathering now, so we could pursue other areas, other jobs, okay? Oh, I've got a trade, I don't have to go collect the wheat now, I can go and learn how to use this steel, make stuff. Oh, someone wants it and I want that, let's swap trade. Trade, those trade routes, okay? So bigger collective learning, better sharing ideas, we've got writing, printing, domestic animals, ships, roads. So this has all led us right up to that moment where it all took off, the Industrial Revolution. So this is getting us right into the modern revolution. So why did change accelerate? What how has the modern world been created? Making of the modern world ring a bell to anyone in the history curriculum? So, you know. This is why I love big history for a lot of reasons. And they don't pay me, so I'm not, well, I did pay for my flight, so that was nice. But, you know, I'm employed through Tassie, so I'm not saying this because I'm being, you know, given a paycheck to. Chloe was wonderful. She was already into this. We're good mates, and she was telling me about it. And I was like, sounds great, but I just had a baby, so I was at home on maternity leave going, yeah, you've really taken off in your career. I've just had a baby. The baby's in care now, so it's all good. So, he's at home with Daddy with hand, foot and mouth disease. That's really good. Bye, darling. But this is one of the things that I love about it. When Chloe was telling me about it, I was like, oh, I love the idea that it's all coming together, but I love that you actually get this picture, the big picture. So, yeah, like Tracy was saying, ancient civilizations, yeah, you can teach that because that's what you do in grade 7. You teach ancient Greece and Egypt and Rome and China and India, yeah? So, you know, but it's so disconnect. And this is the great thing about it, that we can go, okay, well, 8,000 years ago this was happening, 200 years ago this was happening. This is a long time to get from this to this, from writing systems to long distance communication. But in 200 years it's gone from that to that. This is a massive acceleration. So what is causing this acceleration? Okay, even just in the Industrial Revolution, just in the last 200 years. Okay, massive acceleration just in the way that things are produced. But of course, these complexities bring with them some issues and things that we need to solve as well. Okay, and again, just showing that acceleration. That we've gone from carts and donkeys and mules and horses over centuries to this. That's a huge leap. But now to that, such a short amount of time. So acceleration. Okay, and again, people are going, oh yeah, curriculum. So, I mean, it says it all there, really. But the way that it's accelerated has led to, and I touched on this before, how for the first time in the Earth's history, a single species dominates the biosphere. And Chloe's going to show you some learning tasks later that are based on the Anthropocene. So we'll go into that some more. And that brings us, sorry, this is a very condensed version. And I know those of you that are teaching big history, we're telling you how to suck eggs, but for those who don't, we feel it's really important to see that narrative, even if it's a really quick one. Because as Tracy was saying, the importance of this is the narrative, the way it all is brought together. And so the last one is, what does the future hold? Where have we been? What does the future hold? Okay, now this is a lovely time for our students to start to really use their critical thinking skills. It's all through big history, but this one is huge. To take everything we've learned about the last 13.8 billion years and go, well, knowing that, what's going to happen? What's our next threshold? When we look at all those ingredients and Goldilocks moments that have created these new complexities, where are we now? What are the key ingredients that we, or what do we think the key ingredients are now? What are the Goldilocks moments that we're either in or coming to? What is that next threshold or complexity going to be? It's mind-boggling for us. It gets me. So it's going to get our kids, and it does. So you can go, okay, what's going to happen in the next 10 years? The big question for us, of course, is how will we balance this with sustainability? How can we keep going the way we are and maintain living here on our little blue planet? What will the next threshold be, as I said? Now this, I'm paying tribute to a colleague of ours, Kent. And I'm not going to do it like he did. Don't worry, Tracy, I won't be for half an hour going, because that's what he did. But he made a really good point that I wanted to touch on. When you're thinking about the future, I was thinking more, yeah, the future, we don't know where it's going. And he put it in a beautiful way. I'm going to do it very quickly though. He explained to us how the sun, at the moment, is halfway through its life cycle. So everything we've talked about, this entire narrative that Chloe started us with, when there was nothing and then that bang and then elements and da-da-da, I won't pretend to know. Okay, all of that happened, go from the curtains, we're going from the curtains, okay, see here to now. That's half the sun's life. We humans, of course, if let's say that dot there is now, all this human stuff started there, and all this really massive acceleration stuff is like a millimetre along that line. It's what we have done in our time on this earth is immense, to take over the entire biosphere. And when you consider how long we've been around and how much has happened in our sun's life since the sun came into being, how much has happened? Single-celled organisms to the complexities of today. Now it's halfway through its life, so we've got until this curtain, so another couple of billion years or so or more. Okay, what the hell's going to happen? And when you think of what has happened, not just in our human history, but in our sun's history, in our Earth's history, then that's mind-boggling, and that's something that the kids need to think about. Okay, it's limitless. Is it limitless? I think I'm going to wind up. And of course, I always like to bring it back to this for the kids. What are they going to do? How are they going to impact? Okay. That's a little spiel from my last slide. Anyway, that's my school. It's not a very good shot. If I was looking the other way, you'll see the beach. It's quite nice. We have lunchtime on the beach. What are we doing at my school? So I'm at Taroona High School. It's just outside of Hobart. It's a public co-ed school. We're bringing in Big History as an elective next year, but I don't want to continue it as an elective. I want it to be where kids can go, okay, well, I've done Big History, so I've done Year 9, 10 Science, I've done Year 9, 10 Geography and History. As it says here, Science curriculum matches beautifully, Geography curriculum matches beautifully, History matches really well, but there are things missing. If we're going to tick off the Australian curriculum, we're going to have to chuck in a war or two or do something, okay? So now this is where we start to turn the spiel onto specifically the curriculum. So I'll continue on here and then I'll hand you back to Chloe. So you can see, this is straight, well, this is Australian, so this is not New South Wales, but we read all yours last night and we can see where it matches up as well. And, you know, I won't teach you how to suck eggs because your history and science teachers, you know the curriculum as well as I do. Probably better. So this is Year 9, 10. This is skills, so not content skills. It's all ticks because all the skills are there. Content, you can see there's more gaps, and particularly in the Year 10. Okay, Year 9, it matches beautifully. And as we know, and I've just outlined it there, so Year 9, Industrial Revolution, movement of people, expansion, economic ideas, and in particular capitalism, Darwinism, imperialism, importance of consumerism, global impact of the Industrial Revolution, and perfect for grade 10 globalisation. Okay, these are my thoughts. This is what I'm thinking, or some of my thoughts. As I said, I'm trying to get, because at Year 9, 10, I'll leave Chloe will talk about that. I think if you're looking at 9, 10, and we are looking more at 9, 10, it does fit quite well. You can do Big History and say, yes, they've done their science, we can, you know, blah, blah. Much fits perfectly, some doesn't. As I say in my last point there, it's about us being flexible. We know we don't have to do all the depth studies. We choose a couple to do. How in depth do we do them? How much time do we spend on them? It's up to us, really. We can add what we need. For example, when teaching Unit 8, Expansion Interconnection, I'm quite, you know, we're talking about expansion and connection of, you know, globalisation of the world, so just before globalisation, but expansion, interconnection, trade. So that leads us into talking about empires, okay, imperialism, learning about World War I, so it all fits. And Big History doesn't ignore the wars, it is in there, okay. So it's up to us. We can add some more. Or if you don't want to interrupt the existing narrative, when we're finished, we can say, well, let's go back and have a closer look at how expansion, empires led to imperialism and led to World War I and World War II, which of course is World War I take two. Okay, so you can add those in. Discussions of the modern world in Unit 9 can use specific Australian examples in order to complete the Year 10 curriculum. Okay, so when we're talking about globalisation and the modern world, we can, I'm telling you how to suck eggs, we can make it fit. It's like Chloe was saying, it doesn't have to be a square peg round hole. We can be flexible.
Yeah, well, I mean, I think that's a really good point, and that flexibility is the thing that we really, everybody here is a professional, and this is a resource. You know the curriculum, you know your resources. So nobody's saying that this has to be a prescriptive kind of thing. It's great for us science teachers because it really does fit, in some ways, and let's be honest, actually more than it does with the history. If you're talking about that fit in Year 9, 10, and it doesn't have to be Year 9, 10, it's just that's where it was initially pitched. So that's where the resource level was,
I teach science as well, and we use a lot of that, or I use a lot of that. Introducing the elements.
Yeah, it's great stuff. I mean, it is a resource and it is for you, and as Tracy said, this is your course. It's not communism. We're not telling you open book and teach from here. This is a resource for you. So yeah, great for the science, heaps of ticks, it all fitting. This is just screenshots just from Year 9 and 10, but as I said, there's heaps in there. You guys are knowing it. We're going pretty quick. Lots of skills, lots of human endeavour stuff. Moving right along, geography coming up. Anybody who's already teaching a bit of geography will know that a lot of the stuff in the future, environmental change and management and human well-being, that's really stuff that we can talk about. So we've come on this journey, we've come right through big history. What do we know now? What are we going to do into the future? How are we going to make this place, habitable, the well-being of the people that populate it? So again, all those sort of studies come out with there. Now, because we're just racing through time, there's heaps in there for English. It matches up brilliantly with all of the extended writing tasks. That literacy focus is really strong in a lot of it. The critical and creative thinking comes out with just about everything that works with the claim testing, the skills, those sorts of things. Where every piece of knowledge in here, Big History is asking, how do we know that? Why is it important? How can we explain that and justify it with evidence? So lots of the tasks involve, analysing things, working out with logic, all that sort of stuff. There's just heaps of critical and creative thinking in there. Sustainability, of course, cross-curriculum. A lot of that is really towards the end half. The science can come into it, but there's heaps in there again that you can build in. This will be available for anyone who wants copies of it, just in case you haven't worked it out yourself, but it's in there. The thing that I think is important is it really is a skills course. So obviously the content's covered, but if you take Big History, this will set you up with so many good skills to support and augment every other course that you're taking in the school. So whether it helps your science, helps history, helps future studies in anything, the skills that you can learn of those views and perspectives and scale and critical thinking will just set up students really well for whatever else they decide to take. Now, I've kind of graphed it really quickly. It's not to scale, but this is where I think, the rigid Australian curriculum meets the Big History resources as they are presented without you doing anything else to them. All right, so if you just were to look at Big History that's there and how it fits across the units, let's be honest, science fits well, geography is pretty good. There's stuff in there in history if you make it fit. And I reckon that is a pretty good summary of what you guys can do. So we get a backbone. Big History is the story, that's the narrative, that's everything. Make it fit with the curriculum by adding in the web links along the side, how you see that you can add them. Put some stuff in that works, change a bit that doesn't. If you're a school that thinks, I am going to embed Big History as a compulsory subject and I am going to use it to tick off on the Australian curriculum, you can do it with your creative brains and collective learning. Talk to everybody on Yammer, collective learning. So it just needs to be organised in a way so that you feel that you can check off what you need to check off, and if there's anything else that's missing, revisit it by using Big History as the story and run it all in there. So nobody's here to tell you how to do it, we're just throwing up some ideas on what you can do with it. Some people are obviously running it so that, I've just got to go really quickly now to finish up, but so you can run it through so the students take the whole course in a sequence, so they start off taking the science, possibly even taught by a science teacher, and as those same students then move into the second half of the unit that can then be picked up and delivered by the history teacher. So you can still run it like that. If you're somebody who decides to teach the whole lot and you're worried about teaching out of area, go to the community section because everything's mapped in there. As I said, the New South Wales one, the Australian one, all of the things, they're all coming. In this community section of the Big History website, you will find a lot of information that you need to show you exactly where it fits, exactly where it doesn't, and then ideas on what you can do to make it fit if you are choosing to use it as a compulsory subject, not just an elective where it's perhaps not quite so necessary. If you feel, you're teaching out of your subject area a bit, you're not actually expected to know everything. But the teacher, this is a fantastic opportunity to model that excitement and joy of learning new stuff with your kids. It's okay to say, I don't know what happens in the middle of a star. I don't know what happens, that middle bit of the agricultural revolution, or, don't worry about it. You can learn with your students. You can say, this is exciting because, this relates to you because, you are here today because, now let's learn about it. So we're available to talk more about the wonderful joys of the Australian curriculum at your depth and at your leisure. But the one message that, I think really we just need to say is, it's really that dead fish, really. Hang on, it's that. You can use it to tell the story. You can add the bits in to make it fit.